Hello and welcome to Chapter 4 example set for program verification. In this examples, we will have a look at proof of partial correctness and see a few examples of based on the rules of partial correctness. So before we jump into the examples, let's have a look at the rules. First one is a composition rule. So if a precondition, you run a code, you get a valid post condition eta, and eta becomes a precondition to another code, then they can be combined to form this. So this is the composition rule. And the assignment rule is if you're given a precondition in which E can be replaced with X, then and you have an assignment statement, then you can use phi, or you can use the assignment statement to input the value back in. For the if statement, if a precondition phi and a statement B hold, then you execute C1. Phi and B does not hold, then you execute C2. That's the if statement. The while statement is a precondition psi is executed until a condition B holds. So once B does not hold, you exit the while statement. So that's exactly how you say this. And the implied, this is a little different. Phi prime is, if it implies phi, that means phi prime is a little more lax rule for phi, and you also have psi implies psi prime, and you also know that this holds. Then you can replace phi with phi prime and psi with psi prime. So that's what is meant by the implied clause. So using these, let's try to run a few examples and see how it works. So the first one is you're given an input statement saying true, and you're given two statements, y is equal to x and y is equal to x plus y, then y is equal to 3x. So that's what is the output condition. So the first statement given to us is the precondition, which is true. Making it a little more stricter based on the implication, implied function, I can say x plus x plus x is equal to 3x. So this is more tighter bounding condition than just anything being true, and so I can replace this using the implied rule. Now I use the statement y is equal to x from here. So this means I can replace one of the x's with a y. This is assignment. Then the next statement says y is equal to x plus y. So doing this again replacement, I get y is equal to 3x. So this is assignment. Now clearly this is the post condition, and so it's a valid verification of the program given here. Now let's look at another example. In this, the program is called min x comma y. If x greater than y, then z is equal to y, else z is equal to x. So we are trying to prove the validity of the statement. That is, we are given a true as the input condition, and if we run the program min xy, then z is equal to minimum of x comma y. That's what we need to show. The precondition is true. Now looking at the if statement over here, so if b becomes phi or b, I can write this as phi or b. My phi here is true, or b, that is x greater than y. Now this is the if statement. For this given if statement, it directly implies, so one easy way to look at implication is to read this statement straight. So it says x is greater than y, or y is less than x, and if it is true, then do this. So I have y is equal to minimum of x comma y. This is implied. Now clearly this is more a stricter condition than the one above it. So now executing the next statement, z is equal to y, you get, I can replace y with z. So z is equal to minimum of x comma y. Now this is assignment. Now we come to the else part of it. So else says true and not b. So not b is not x greater than y. So this is the if statement. Now this implies x is equal to minimum of x comma y. This is implied. Now if you execute the statement z is equal to x, you get z is equal to minimum of x comma y, which is assignment. Now since this holds here and holds here, we get z is equal to minimum of x comma y. This is if statement. That's it. So this is the way we can check the program validity for an if statement. Let's look at a third example over here. In this example, we are trying to prove the factorial program with the set of lines given over here. Given an input condition true, if we execute the factorial code, we get z is equal to x factorial. So I'm given true as the input condition. Then I can say 1 is equal to 0 factorial. This is implied. Now you have y is equal to 1. So from this I get y is equal to 0 factorial. This is assignment. Then I have z is equal to 0. That means y is equal to z factorial. This is also assignment. Then we have while z not equal to x. So if you again go back and look at the while condition, it becomes phi or b. So for the while b, it becomes the precondition or b. So we have, what's the precondition for while? Y is equal to z factorial. So I can write this as y is equal to z factorial and z not equal to x. So this is partial while. I can say, using the assignment on the top, y times z plus 1 is equal to z plus 1 factorial. That is just multiplying z on both sides. So it is implied. It's just the same condition. Now putting z is equal to z plus 1 gives y times z is equal to z factorial. This is assignment. And then I have y star z is equal to y. So from this I'll get y is equal to z factorial. This is assignment. Sorry, this is y over here is equal to, and when it exits the loop, we have y is equal to z factorial and not of z not equal to x. This is the partial while. Now from this, not of z not equal to x implies z is equal to x. So putting that, we get y is equal to x factorial. This is implied. Hence, we have proved the validity of this entire program. So this is the way we use the rules that have been provided to check the validity of the program. So remember the precondition, and we should get an output of the, given a precondition, we should get the output of the post condition. For more examples, look at section 4.4 and the videos provided in the, on the Canvas shell. Thank you.